Chapter 13 is all about trigonometry, and section 13.1 starts out by talking about right triangle trigonometry, which, as you can guess, is trigonometry using right triangles. As you can see, it says trigonometry is a study of the relationships among the angles and sides of a right triangle. Now, the classic trigonometric functions that we know can go along with the mnemonic device SO, CA, TOA. Oops. And what this means is, if we have an angle theta, this angle here, and there are the sides that are opposite to that angle, so across the way. There's the side that is adjacent, so right next to it, and there is the hypotenuse. Now the hypotenuse is always going to be the leg that is across from this right angle. So hypotenuse never changes, but the opposite and adjacent can change. Let's say that theta was over here and not this one, then over here would be opposite, and over here would be adjacent. So it all just kind of depends on where your angle theta is that you are looking from. So anyway, SOHCAHTOA means that if we are looking at this angle theta, and we want to know the sine, which we can abbreviate as SIN, the actual word is sine, but we can just use SIN. The sine of theta is going to be the opposite side over the hypotenuse. So whatever this length here is, divided by this, that is your sine. CA means the cosine of theta is the adjacent length over the hypotenuse. So again, whatever this value is, divided by this. And TOA means that the tangent of theta is the opposite over the adjacent. So this length over this length. Now each of these trigonometric functions have an inverse. So the inverse of the sine function is actually what we call the cosecant of theta, and that would be the hypotenuse over the opposite. Inverse of the cosine would be the secant, and so that would be the hypotenuse over the adjacent. And the inverse of tangent would be cotangent. The cotangent of theta then is the adjacent over the opposite. Now that we know the basics, the 6 basic trigonometric functions, let's see how they work and interact with one another. So if we wanted to find the 6 trigonometric functions for angle G, so we're looking at this angle. This is our theta. So we would want the sine of G, the cosine of G, the tangent of G, the cosecant of G, the secant of G, and the cotangent of G. Well, remember, sine of G is going to be its opposite over the hypotenuse. So it looks like this is our hypotenuse. If G is over here, the opposite one is going to be over here. And adjacent is the one that lies right next to it. So our adjacent is going to be this one here. So again, if sine is opposite over hypotenuse, we would say it's 24 over 40. And if we reduce those by dividing each by 8, we would have 3/5. So again, using our sine and knowing that the inverse is the cosecant, we can just flip those around and say that the cosecant of G is 5/3. So looking at the cosine, remember cosine is adjacent over hypotenuse, we would have 32 over 40, which again, dividing each by 8 to reduce, would be 4/5. And the secant of G is, again, just the inverse, so we flip that, so that would be 5/4. Let's try the other way with cotangent and tangent. Remember, the cotangent is going to be the inverse of tangent, and tangent was opposite over adjacent, so the cotangent would be adjacent over opposite. So it would be 32 over 24, which we can reduce down to 4/3. So again, tangent is just the inverse of that, so we can flip that around and say the tangent of g is 3/4. So not too terribly difficult. The sine, cosine, and tangent of 30 degrees, 45 degrees, and 60 degrees will all need to be memorized. These ones you will use a lot, both throughout this course and other courses and beyond. As well, in real life, these angles are probably used the most by carpenters, architects, anyone trying to build anything. They always use 60 degrees, 30 degrees, or 45 degrees. So they get to know these values very, very well. So if we look at the sine of 30 degrees, so we're looking at this one here. Remember, sine is opposite over hypotenuse. So we'd say that it's x over 2x. And what that means is, let's say that our x is 1. So we're setting this value to 1 length here. This leg would be 2 in length, and this leg would then be square root of 3. So we could say inches. This is 1 inch long, 2 inches long, and root 3 inches long. These proportions will be the same for any 30, 60, 90 triangle. So if the sine of 30 degrees is x over 2x, we can reduce that down to just say 1/2. Now if we're looking at the cosine of 30 degrees, again, that's going to be the adjacent over the hypotenuse. So we would say that it's root 3x over 2x, which again we can reduce down to root 3 over 2. And the tangent of 30 degrees, remember, is the opposite over adjacent. So we would say that it is x over root 3x, which we can reduce to 1 over root 3. But we don't want to keep radicals in the denominator, so we have to multiply both the numerator and denominator by square root of 3. So that would reduce to root 3 over 3. So this is our sine, cosine, and tangent of 30 degrees. Similarly, looking at 45 degrees, we'll pick this one as our reference angle because there are 2 of them. But we'll look at this one specifically. So its opposite is this one over here. The adjacent is the one right next to it, and the hypotenuse is always the one across from the right angle there. So sine again is opposite, this piece over here, x over the hypotenuse, so x root 2. Reducing down gives us 1 over root 2. And again, we don't want the radicals in the denominator, so we would reduce that to root 2 over 2. Cosine of 45 degrees is adjacent, so again x over hypotenuse. And again, we want to reduce that down to 1 over root 2, but we don't want radicals in the denominator, so we'd say that is root 2 over 2. And the tangent of 45 degrees, remember, is the opposite over adjacent, which would reduce to 1 over 1, so we would just say that it is 1. Now looking at the sine of 60 degrees, we'll look at this piece over here. Again, that's the opposite, which is now this piece. Adjacent is here, and the hypotenuse does not change. So we'd say it's the opposite over the hypotenuse. So we would reduce that to root 3 over 2. Cosine of 60 degrees, again, is the adjacent. So we just say x over hypotenuse, which would reduce to 1/2. And the tangent is going to be the opposite over the adjacent, which would reduce to root 3 over 1, or we could just say square root of 3. So these values here are 1/2, root 3 over 2, root 3 over 3, root 2 over 2, root 2 over 2, 1, root 3 over 2, 1/2, and root 3. These will need to be memorized for your upcoming quizzes.